variable with this name. These underscore names are recommended sometimes because it's like if you leave a name like John equal to integer 3, sometimes you don't know what what you're trying to create. Then they recommend to, because you can use any combination of numbers of symbols after the first letter of the variable. They say place a name and try to use these underscore things. They say it's self-commenting, because if you see, you're like, okay, probably that has an integer. The problem in Python with self-commenting is that the names of the variables can be assigned any other type of data in the execution of the program. Then it could be confusing, but if you are like serious and like saying like, I'm gonna store integers here, only integers, and I want to have an integer, this kind of naming of variables is sort of recommended. Like underscore integer is like, oh, okay. When somebody reads the program, immediately it's like, this should be an integer variable. And if they don't see an integer value in this variable, variable, then they will be suspicious that something you are instructing the computer to do something that is not intended. Then we're gonna do this one. Then is creating a variable called my underscore integer, and it's gonna assign a floating point value, but it's going to pass through this integer function. And this integer function, what it takes is it takes any value and makes that value an integer. Then I'm gonna write something first here. I'm gonna do a print, and I'm gonna say print the integer part of this particular floating point value to see what is that value. Then it's like 3. If you take a floating point value and then you give it to the function integer, it only produces the integer part of that particular value, and that value is of integer type. If I say, give me the particular value of that expression with type, then it's going to say is the value is 3 and the type is integer. Then when I do the assignment here, even though I'm giving a floating point number here, I am doing this. Sometimes they call it casting, because it's like forcing the values to become into another type. I'm giving a floating point number and I'm casting that number into an integer, and I do the execution, I get this. The mistake that I get here is that for the printing in Python 3, I need square brackets around. Then that's floating point variables. Then we have 3 types of variables: integer, floating point numbers, booleans. But then they're gonna go into booleans in the first step. The third kind of thing that you can assign to variables in Python are strings. Then a string can be assigned with single quotation marks, but also with double quotation marks. Like the way that you can assign a string of letters to a variable can be done in both ways. Here, the only change that I have is like, because in Colab, by default, he opens the things in Python 2 and Python 3. All my prints should be, the expressions that are being printed have to be in these ones. Then it produces the same value. There are 2 ways to assign strings of change of characters to variables, with single quotation marks or double quotation marks, and that's what they tell you here. They say strings that are change of characters can be assigned to variables, and you can do either with double quotation quotes or with single quotation quotes. But they are allowed, but if you open with one, you should close with the same one. And they say why they include 2, because sometimes you want change that include double quotation marks. Then if you want to create a string that has double quotation marks inside, then you have to open with this and close with this. If you want to use another that uses single quotation marks, like this one, then you have to open with double quotation marks and close with double quotation marks. Then they say they are both allowed, but you cannot have with double quotation marks a double quotation mark, because when he finds the double quotation mark, he will assume that is the end of the string. We're gonna do a little example here with this thing. Then just copy this code to this way. The only change that we have to do the code from the code that is in Quantopian to the code here is to change this here in Colab. Then just for the heck of it, I'm gonna put another quotation mark here inside. Then even here, the language is gonna tell you, this thing is gonna consider the string open here, you have all these characters and this thing close here, and it will consider this a mistake because this is neither a comment nor an instruction in Python. It's like, yes, I have a string, but then you have something here that I don't know what you want me to do because the string finished here and then you try to print, but I don't know how to do with this comment. Then I can only have opening and closing in that particular one. The same thing with the double quotation mark. If I try to include a double quotation mark inside, it will consider you open the string with this one, and the first double quotation mark that it finds, it considers the string was closed, and it will consider the rest a mistake because it's not a comment. If I want to make this a comment, then I can include this, and it's like, okay, from this pounds on, this is just a note, it's no coding, it won't have a problem with that particular thing. Then these are the third type of variables that you can include. You can include a change of characters or just one particular character. Sometimes, let's say I say I'm gonna create here another one, ch, and I create just one character and I print that one. It could be a sequence of characters or just one particular one. And you can use both kind of things to create a character, either the double quotation or the single quotation. Okay. Then most of the things that are like labels or things like that in graphics that we're gonna use strings. The graphic receives as a label or as a title of the graphic. A string is the parameter that it receives with some values, and a string that it needs to be assigned to that particular thing. Then sometimes you see in examples that they create the string with double quotation or single quotation for the title of a particular graphic that we may use later. Then I'm going to execute these cells here in Quantopian just to show that the same thing works in Quantopian and in. The only thing is like here, because they are using Python 2, even though it says Python 3.5, in Quantopian they allow the old Python 2.7, then you can still execute these things without the brackets. When you go to Colab, you have to put the core brackets around the prints, if not, it will produce an error. Then the last one type of variable, the last type of values that you can tell the computer in Python to create and store variables is a type of variable that is called Boolean, that it has a value of true or false. And you have operations that we will see later that you can do. With integers, you can add integers, you can multiply integers, you can add, multiply, and divide. Floating point numbers, you can do things with strings like extract a substring, like things like you can join two strings. There are operations between these types of variables with values, particular operations, and with Boolean variables, you can do logical operations. They mention here logical operators. okay, that are ahead. That is, you can say if two things are true and you join them with a conjunction and, then they will be true, or you can do or you can do the negation of a variable that is Boolean. In the graphic, sometimes some of the attributes of the graphic are Boolean. You say display labels is true. Then sometimes they include numbers because the variable include numbers, but sometimes they include strings for like the title or the labels or like the names of the values in the access. And sometimes in the options to display graphics, you have Boolean variables saying like, I want this particular like characteristic of the graphic. Then you add that particular like attribute and say true or false if you want it or not want it. Then those are the 5 types of variables that you can declare in Python. Either here there is a little example, and because I'm moving this to collab, you can create a variable that is true. It says it's true, bool. I can only assign those 2 possible values. The variables, the Boolean variables can have only true or false. You see that this value is, as soon as you write it and you complete it, it becomes blue. But if I say assign to my bool f, it's like there is an error. To a variable, you have to assign one of the valid variables, like constant values that you can have. You can assign an integer, a floating point, and a string. But I can assign to a Boolean variable, even though it's named Boolean, I don't know, 1. Then what happens is, even though I call my variable, my bool, I assign 1, then it becomes an integer. But if I want to assign a logical value, the 2 values that are valid in Python for assigning logical values are true or false, only true or false. To integers, you can assign integers to any size. Like in other languages, you can usually assign small numbers, let's say 1, 2. But if I want to assign a very large number to an integer, I'm going to say here my val1. In other languages, you can only assign certain limited values to integers. In Python, is as much memory as you have. Then you assign that value, and probably you say my val2. I'm going to assign some other number here to make it different. And I'm going to say print the product of those 2 things. Then it's going to be a humongous number. Python doesn't have any problem multiplying very large integer numbers, as large as you want. There is an operation that we're going to see later that is like power is going to be a humongous number, because it's going to be have like elevating this number, multiplying this number of times. It's a humongous number. It takes a very long time. But Python doesn't have any limitation. Other languages for integer values, they only have like 32 bits. Then you have numbers between, I don't know, 65,000 and minus 65,000, or 68 bits. And then if the integer number doesn't fit that particular pattern, then it will give you a mistake. Here it's going to take a little longer. Probably I'm going to stop this one because it's going to take forever, because it's doing an operation that takes very long. But Python doesn't have any problem with the size of numbers. It was created to try to remove problems from the people trying to write instructions for computers. Then they would like, if it's something that we can solve, let's solve it. If we need more memory to represent the numbers, ask for the memory. It doesn't have limits in the integer types of numbers. This is going to take forever. Then I'm going to stop the execution of this one. I'm going to delete the cell, and then probably will stop the execution. Okay. Then these are the 5 types of variables that you can define with the particular values. Actually, the value, the type of the variable is taken from the last value assigned. You have values like integer, floating point values, strings or characters, and true or false. And if you assign any particular constant value, the variable that takes that one takes the type of the value that contains in that particular number. Then these are the 5 types of variables that you can have in Python, no more. Then, what kind of operations? Python is like a calculator. With certain types of variables, you can do operations. And with certain, even with constants, you can do operations. Then this first one is saying, you can add integers, multiply integers, like integers, do division of integers, and do powering of integers. The only change that we have to do here from here to collab is that, sorry, again, copy the code, is that in collab, because we assign this thing, is gonna say these prints don't have surrounding brackets. A message, comma, some expression, and you can have, let's first fix these ones. Print 7 minus 4 is 3. Actually, I can do the opposite because here they handle negative numbers. Then if I do this, it's gonna say, okay, this value is minus 2. You can do multiplication, you can do division, and you can do exponentiations of constants, or also variables of different types. I'm just gonna do another little example for you guys to do. I can do this. Actually, this you can print things, messages, expressions, comma, another messages, another expression, comma. Then in a print, you can have multiple things separated by commas. It could be strings or expressions that Python can calculate. Then Python that does the calculations and prints the values. Then they say here the basic math is that you have addition, subtraction, division, multiplication, and powering for any other things. There is a special operator that is this thing that is called residual or modulus. Now we're gonna do here, just Python. Doing this is dividing 15 by 4 and saying if you divide 15 by 4, it's like 12, 3, because it doesn't fit the 4, because it will be 16, and it's saying what is the remainder of 15 by 4. What it's gonna tell you if we say 21 is like, if you divide 21 by 4, it's gonna give you 5, and then a remainder of 1. This is the remainder of the division. That's another operation that you can do also is in the calculators, and that's another symbol. Divide this by this and give me the remainder of the division, not the result of the division. If I divide 21 by 4, because they are integers, it's gonna give me the integer part of the division. It's like 5.25. If I want only the integer part, I say, okay, do that division, and after doing the division, give me the integer part. It's gonna, if you divide 21 by 1, it's gonna give you 5, the integer part of the division. If you do this, you're doing the division, but because it doesn't fit into an integer, it's saying like, it's 5.25. But if you say, I want the integer remainder, the remainder of the division is going to be 5.4 something. It says 5, and the remainder of the division is going to be 1. Then you have those things to use Python as a calculator, and you can use it with constants, like they are showing here, but also you can use it with variables. This example is saying, okay, they create an integer here, another integer here, and then you try to print the multiplications of those variables. Then you can use it with integers as such, or you can use that with variables. Then you create a variable, assign a value, create another variable, assign a value. Here, there are like things that can happen. Like, as I told you before, if these two things are integer, it will use an integer. If this thing is a floating point, he will do the operation and say, because the second one has a floating point number, this becomes a floating point number, and the result is a floating point number. If I do a character, it's gonna give me some problem, because it's like, it's gonna do things like this. When you multiply a string by an integer, what it does is write for number of times of the first integer for the particular character. It could be an integer or a string. Let's say I say sat. Then it's gonna write 4 times. It's like multiplying an integer by a string. In some other languages, this will be a problem. They say, you can only multiply integers between integers, floating point between floating points. Then it say, no, I don't have a way to multiply a floating point number with a string. With an integer, I interpret that you are trying me to do like, reproduce 4 times this particular string. It's also in the opposite way. If I say stat and 4, it's like, no, the multiplication of a string by an integer is not defined. The only one that is defined is the integer first and the other one second. Then you have all those things among the operations, but sometimes you have to go and check when you do things between different types, which ones are allowed and what is the meaning of that in Python in that particular language. The standard thing is like, if you have a first thing that is an integer and the second thing that is an integer, if you print the product, is gonna be an integer. That was the first one that we did. Then here multiplication, and then you get that. The second one is that you can do things with floating point numbers, and you can also do things between floating point numbers and integers, but it promotes everything to floating point numbers. If you say first number and second number, here is not like an integer, it's floating point numbers. He does the multiplication that way. If the second one is an integer, he still does the multiplication, but makes the things all floating point numbers. And if it's the second one that is a floating point number, let's say this is an integer and this is a floating point number, 3.1, it makes the whole thing floating point numbers. Then you can do addition, subtraction, multiplication. Powering is something that is a little more complicated. Let's say I say 11 to the power of 2. Powering is like this. Then is this number elevated to the square is 11 by 11. It's 121. I can have this guy to the power of 3. It will be 11 by 11 by 11 3 times. I can have something like this, but it's gonna produce some problems. Like, I don't know. It's something that they use in mathematics. If you use 0.5, is the square root of this. Then if you have floating point numbers in the exponent of a mathematical explanation, powering, in the exponent of the mathematical powering, the integer part is the number of multiplications that you do, and the decimal part is sort of root, like roots, like square roots, cubic roots, things like that. but we're not gonna do this thing here. These are like sort of more sophisticated, but then you have the basic operations, the basic math that you can do in Python is using as a calculator. You can do addition, subtraction, multiplication, division, and powering with certain particular subtleties, but they pretty much work as a calculator. It's extended. Sometimes you can do things between strings and some integers, and these are the things. Also, Python has like a scientific calculator. You can have some functions that are built in. Then they say you can have the absolute value of things. You can have the round part that is like the rounding number. We're gonna see how the rounding number works. You can have the maximum of a set of numbers, the minimum, and the addition of a set of numbers. Then these things are like, we're gonna do like little examples here. Let's say absolute value. I'm gonna have this guy as minus 11, and I'm gonna multiply by 3 and do the multiplication. I'm gonna create a third number that is gonna be this one. I'm gonna print the third number. Then because I have a negative number, I'm multiplying by 3, I have minus 33. And here I'm gonna print the absolute value of that number. Then the absolute value is, if it's negative, it's positive. If it's positive, it's positive. Then I can use those functions at any time. If I need those functions in library or anything, you can have the absolute value. The round value is approximate to the next integer. Then in this one, we have the third number as 33. Let me use here. It's ending in 10 minutes. Then probably now we'll have also to stop like in a little bit. If I have this number, yes, there are two people. I didn't see until now. Then you can use this one. I'm gonna use the round one, and you guys gonna tell me what will be the. This is the multiplication, 30 minus 34.1. If I round this number to the next integer, what is the closest integer? It will be minus 34. If I am like 3.49, this one to 40.49 is minus 43, no minus 42. Then if this number in the rounding operation, if the decimal part is less than equal than 5, it approximates to the integer on the left. And if it approximates to the one, if I have this positive, it will have the same effect. If I have this, it will approximate to the closest integer. It's like, the 43 is really close to this one. 3.1, that is the one that we had before, probably it was something 3.41. It's going to approximate to the one closest to the other side. Then those functions, you have those importing any other library. But also, they have a mathematical library that has more mathematical functions. But if you want to use that function, you have to first import the library of functions that do additional operations. Then I think we're gonna stop in this one because we're gonna be, before doing this probably we lose. You have all these functions. Seal, that is to take the ceiling, calculate floating point absolute values, to calculate factorial, to calculate floor. These are extra functions like to do like mathematical calculations. You have trigonometric functions, you have logarithm and power, you have all these functions that you can use if you need to do mathematical calculations. Then it's like a mathematical calculator, the ones that you have with the keyboard. Sometimes you have some few keys to do operations like square root, powering. In Python, you have an extension, but to use those functions, you have to first import math, and then you can use those functions using the word math. Sometimes, as you guys see, you can rename the library, use like an alias for the library. If you don't use an alias, you have to use the name of the functions as math. Let's say I say import. Let's try to use a function without importing. Let's say string logarithm. Here logarithm is in base 10. If you go and check what does it mean log here in the power in here, you have log. If you don't give the base, it's using base E, like natural logarithm. If you use the comma and base, then it's gonna use those names. And this is logarithm base 2 and this is logarithm base 10. Then I'm gonna use logarithm base 10 in this little example. Then I'm gonna use log 10 of 100. Is to what number do I have to power 10 to get to 100 squared? But then here I'm gonna get a mistake because it's like, I don't know what is math because you didn't do the import math. Then if you're gonna use the math functions, you have to say import math. Then after that, he knows math is this library, and then you're referring here to that particular function. Then besides these 5 functions, these mathematical functions to do these operations, absolute value, round, max, min, and sum, you have a lot of mathematical things and constants. You have the pi constant, the e here, but to be able to use those ones, you have to import math. And after that, in any cell that is behind, imagine here that I have another cell. If I already execute this, when I say math, here is saying, you already have a module imported that is math. And then you already know all those functions. Then I can have here like logarithm base 2 of this guy. And he already knows that the library is math because I did I did include here, I can use it from that point on down in my notebook. I can also, let's try. Then this is to define variables. You can have constants, like constant is gonna print the two values. We know pi, that is 3. Among all the things that you have in Python, you have those constants. Here they mention, what you have number theoretical things, you have trigonometric functions, you have hyperbolic functions. Among the trigonometric functions, probably you have the pi. No. And constant, you have pi, e, and this tau that is related to the circles, something like that, 2 pi. Infinite, you also have a number for infinite and a constant for non-numeric numbers. If something like you have something that it produces a problem in the execution of the mathematical operation divided by 0, something becomes then we didn't stop. I hear 10 minutes and we are